We'll start the session. So take 3 minutes to solve this question. So on one side of the road, of a 1.101 kilometer long road, 101 plants are planted at equal distance from each other. What is the total distance between 5 consecutive plants? So they're saying that there is this. So answer is in meters. So I'll convert the kilometer into meters. There is this 1010 meter road, and they are saying that they're planting the trees here at equal distance. And then they are asking what is the total distance between 5 consecutive plants. So one thing that you have to be very careful is here, if you are planting, for example, if you are planting 3 plants, 1, 2, and 3, the whole distance would be divided by not by 3 but by 2, not 3. Because there are 3 plants, the whole length is divided by 2 sections. There are 2 sections here, section 1 and section 2. So in this case, the whole length is 1010 meters, and they have planted 101 plants. So if they have planted 101, then that means the slots would be the equal distances. Slots would be 100 and not 101. Because for example, if you plant 1, 2, 3, 4, and 5. If you plant 5 trees, there will be 1, 2, 3, 4, n minus 1 slots, equal sections. So in the 100, if there is 101 plants that are planted at equal distance, then there will be 100 equal sections. So this 1000 meters now is divided by 100 sections. So each section would be 1.01 meter length. So this section length from here to here, it would be 1.01 meters. And they are asking what is the total distance between 5 consecutive plants. So if you are in this case, if it is 5 consecutive plants, then the equal sections would be 4. So the total length would be 4 into 1.01 meters, that is 440 sorry, this is 10.01, not 1.01. This 1010 divided by 100 is 10.01 meter. And if you are multiplying it with 4, you will get 40.04. I hope this is clear. If you have any doubts, you can ask. The only catch here is to find out if there are n plants, there would be n minus 1 sections. Yeah, if there is any doubt, please ask. If it's clear also, please let me know. I'll move to the next problem. Sorry. I'm sorry, this is 40.1, not 01. So 10.1. 10.1. And this is 10.1. This is 40.4. This is 40.4. Yeah, the correct answer is option B. Is it clear? It's clear. We'll move to the next question. So we'll move to the next problem. So take 3 minutes to solve this question. So in the series A, ABC, ABCD, ABCDE, which letter appears at the 100th place? So this is A, then AB, then ABC, and then A, B, C, D, E. So how do we calculate which place? So for example, if there are only this and this is, you can see this is like a pattern here: 1, 2, 3, and 4, and 5, and so on. And if we want to calculate the third digit, we have to add this 1 and 2. And if we have to calculate the 1, 2, 3, 4, 5, 6th digit, that is nothing but the sum of this 1, 2, and 3. So to calculate the 100th digit, what we have to do is we have to calculate, here we have to calculate the sum of n terms. In this case, the formula for number of sum of n terms is n into n plus 1 by 2. This is the formula for n terms. So in this case, this will go on like this: 1, 2, 3, 4. Like here there is 4, when this is 5, A, B, C, D, E, and F. So like this is a increasing pattern here. And to calculate the 100th place alphabet, so we have to calculate the sum of the terms which is closer to this 100th place, sum of the natural numbers sum. For example, if I take 10, the first 10 terms, 10 into 11 by 2, so it's 5. This will be 55. But we need 100th term. So to calculate the 100th place term, we'll just increase this. Let's say if it's 12 or 11, sum of 11 terms, that will be 11 into 12 divided by 2. 6 is 66. If I increase it to 13, 13 into 14 divided by 2, this is 7, and 13 into 7, so 21, 2, 7 ones are 7, 9. Okay. So the 13th term here, after the 13th term, that is after this 13, it will start again. There will be 13 alphabets after the 13th terms, and after that only the 100th term will start. So after 91st term would end here. So 92nd would start with A, 93rd would start with B, 94 C, 95 D, 96 E, 97 F, 98 G, 99 H, 100 is L. I hope this is clear. So 91st term would have 13 alphabets, like 13th alphabet. I hope this is clear. If you have any doubts, please ask. This would end here, and after that again it will start with ABCD. If you have any doubts, please ask. People who have got option option D, is it clear? Then we'll move to the next question. So take 2 minutes to solve this question. 3 minutes. So there are people who have got option C and option D. about this question. Option C and option D are opposite answers. So we'll see how to go about this question. So this is a data sufficiency question. Consider the following question and two statements given below. Is X an integer? So we need to get the answer as yes or no. So answer should be in yes or no. We don't need to calculate the value of X. So the first statement is X by 3 is not an integer. X by 3 is not an integer. If it is not an integer, then X can be so X can be 5. For example, let's take it's 5 by 3. So if it is 5 by 3, again this X by 3 is not an integer, but X is an integer. X by 3 is not an integer, but X is equal to 5. That is an integer. So clearly X can be integer. So this is wrong. So sorry. So with statement 1, we cannot say whether X is an integer or not. X can be an integer and also a decimal. So we'll take statement 2. 3x is an integer. 3x is an integer. So we know that 3x is an integer, but x can be an integer and it can also be a decimal. How x can be an integer? For example, if 3 into 5 is equal to 15, 15 is an integer. So x is an integer. But I can also say 3 into 5 by 3. 5 by 3 is a decimal. If 3 and 3 cancels, but this will again give you an integer. So when you multiply 3 with a decimal also, you can get an integer. So you cannot clearly say whether x is an integer or not. The statement alone is not sufficient to answer this question. What if I combine this? X by 3 and 3x. X by 3 is not an integer and 3x is an integer. So for example, even here, even if I take, for example, the 5 by 3 itself, x by 3, if I take x as 5 by 3, 3x, x by 3, if I take 5, x as 5, x by 3 is not an integer. And 3x is an integer. Here x is an integer. But I'll show you x can also be a decimal. What if x is 5 by 3 itself? When x is 5 by 3, here let x be 5. What if x is 5 by 3? In this case, x by 3. X by 3 is not an integer, and 5 by 3 into 3 is an integer. So when I combine both these statements, even then I cannot say that x is an integer or not. So after combining both these statements also, that is x by 3 is not an integer and 3x is an integer. After combining these two statements, I cannot conclude whether x is an integer or not. X can be an integer and x can be a decimal also. And both these statements would be can be true when x is an integer and x is a decimal also. So the correct answer is option D. Both the statements are not sufficient to answer the question. I hope this is clear. If you have any doubts, please ask. For example, take for example 5 and 5 by 3. If x is 5, so both the statements will be true. But if x is 5 by 3, again for 5 by 3 both the statements are true. But you cannot say if x is in one case x is integer, and in one case x is 5 by 3. It's a decimal. Okay. So is the individual statements clear? That is, x by 3 is not an integer, and I mean x can be both an integer and x can be a fraction also. I'll just explain it once again. See, what they're saying is they're asking whether x is an integer or not. First statement they are saying is x by 3 is not an integer. So x by 3 is decimal. X by 3 is a decimal. So x is 3 into a decimal number. X is 3 into a decimal number. So x can be both an integer and a non-integer. So there are both two cases. We cannot say clearly whether x is an integer or not. So statement 1 alone is not sufficient to answer this question. Now taking the statement 2 alone, 3x is an integer. Now 3x is an integer. For example, if I take x as an integer as 5, I would get 3x as integer. But even if I take if x is a decimal, that is 5 by 3, 3x is also will be an integer. So 3 into 5 by 3, 3 cancels, 5 would be the answer. So even then the 3 into x is an integer. But in this case, there is x can be both an integer and a non-integer. So clearly even statement 2 alone is not sufficient. So this is wrong. Statement 2 alone is not sufficient to answer the question. Now what if we combine this? That is x by 3 is not an integer and 3x is an integer. No, x can be integer. X can be an integer. And x can be a decimal. So we cannot clearly say x is not an integer. If the answer is no, that means x is not an integer, but x can be integer. For example, if I take x is equal to 5, that 5 satisfies both these conditions. 5 by 3 is not an integer. 3 into 5 is an integer. So an integer is satisfying this condition. And if I take a decimal, that is 5 by 3. If x is 5 by 3, 5 by 3, if x is 5 by 3, this is 5 by 9. That is not an integer. Statement 1 is true. 3 into 5 by 3 is 5. That's also an integer. So even 5 by 3, a decimal number also is satisfying both the statements. An integer is also satisfying both these statements. So x can be, even after considering these two statements, x can still be an integer and a non-integer, that is a decimal. So we cannot say x is an integer for sure. X can be both integer and a decimal. So clearly we cannot have a yes or no question answer here with just these two statements. So the correct answer is option D. I hope this is clear. If you have any doubts, please ask. Yes, x can be a decimal. For example, if x is equal to 5 by 3, if I take 5 by 3, 5 by 3 is a decimal number. So 5 by 3 here, this will be a non-integer. 5 by 3 satisfies both the statement. That is 5 by 3, this becomes 5 by 9, that's not an integer. And this 3 into 5 by 3 gives you 5. So 5 by 9, this satisfies the statement 1, 5 satisfies the statement 2. So here x can be both an integer and a decimal. And both an integer and decimal will satisfy the statements. And so you cannot clearly say whether x is an integer or not. Prajwal, is this clear? Any others? If you have any doubts, please ask. And if you have any doubts, please ask. Don't hesitate. I'll be happy to clear all your doubts. So it clear for everyone then? Or should I move to the next problem? Okay, we'll move to the next problem then. Take 2 minutes to solve this, 3 minutes to solve this question. So let P be a 2-digit number and Q be the number consisting of the same digits written in reverse order. So if it is AB, the reverse order is BA. And if you multiply, this is P, this is Q. If P into Q is 2430, then what is the difference between P and Q? So they are asking what is P minus Q. So one way is to for the regular method where we take this as 10A plus B and then 10B and A, and then use multiply that, and that calculation would be very cumbersome. So other way is to do take this and divide, factorize this. 1 0, 2 2 0, 3 4 0, 5 0, 5 8 0, 1 0, 3 7 0, 3 3 9 0. So 2430 can be written as 2 into 3 raised to 5 into 5. So we need to find out two numbers where when it is multiplied. So AB into BA will give you 2430. So since the unit digit is 0, we want one number to end with 5 and another number should be an even number. So one number should end with 5. So A or B has to be 5. One has to be 5. The other has to be an even number. It can be 2, 4, 6, 8. It cannot be 0 because it's a 2-digit number. So we have these four alternatives for 1, and the other alternative is fixed, that is 5. Because this number is 0, so there has to be a 5 there. So we have only one 5 here. We have 1, 2. We want a number here. So one would be, so BA or AB has to be 5. So we'll take here the other term as 25. 25 into 52. We'll just check what is the number. 2s are 10. 2 2s are 4, 5. 5 5s are 25. 5 2s are 10, 12. 0, 10, 3, 1. 1300. We need 2430. What I'll do is, next number is 4. So 45 into 54. 5 4s are 20. And 4 4s are 16 plus 2 is 18. 5 5s are 25. 2. 5 4s are 20, 22. This is 0. 8 plus 5 is 13. 1 plus 1, 2 plus 2, 4. 2430. This is 2430. Yes. So 54 into 45. 45 into 54 gives you 2430. So one number here, A is 5 and B is 4. And they're asking what is the difference between P and Q. So one is 54 and 45. And the difference between these two is 54 minus 45 is 9. The correct answer is option D. I hope this is clear. If you have any doubts, please ask. It will take 3 minutes to solve this question. So there are options, responses for option D, option C, and option B. We'll see how to solve this. Consider the following statements in respect of two natural numbers p and q such that p is a prime number and q is a composite number. So p is a prime number and q is a composite number. Composite is it's formed by two or more prime numbers. So they have given these three statements and we have to check whether which of this is correct. P and Q can be an odd number. Yes, P and Q can be an odd number. For example, let the composite number be 3 into 5. So let this be a composite number and let P be prime number, that is 2. So if I take this example, P into Q is an odd number. No. For example, if I take P as 3 and Q as 3 into 5, so this thing is an odd number. There is no even number. So yes, this can be correct. And Q by P can be a prime number. So Q by P. So if I take P as 3 and Q as 3 into 5, so Q by P equal to 3 into 5 divided by 3. So this is a prime number. Again, this can be correct. And then P plus Q can be prime. In this case, please read this can. Even if there is one chance, one possibility, then this will be a true. And this will be a true statement. So P plus Q, let the P be 2 plus Q be 3 into 5. This is 2 plus 3 into 5 is 15. 15 plus 2 is 17. 17 is a prime number. So even 3 can be correct. P plus Q can be a prime number. So all the three statements can be true. So statement D is correct. I mean, option D is correct. So is this clear? If you have any doubts, please ask. We will move to the next problem. So take 3 minutes to solve this question. We'll see how to go about this question. They're asking what is the remainder when 91 into 92 into 93 into 94 until 99 is divided by 1261. So the main problem is now we need to know if this whole number is divided by 1261, what is the remainder? So first we need to factorize this 1261. So whenever we are factorizing, we start with the least number, the prime number. So 2, this number is not odd, is not an even number, this is an odd number, so it is not divisible by 2. 3, 1 plus 2 plus 6, 9 plus 1 is 10, so it's not divisible by 3. 4, the last 2 digits, I mean, this is not an even number, so it is not divisible by 4. It is not divisible by 5 because this is here 1 is there. Not divisible by 6 because this is an odd number. 7, I'll just check with 7. This is 12 by 12, 61 by 7. 7 ones are, and then 5 is 6. 7 sevens are 49. 7 eights are 56, sorry, and then 1 is there, so this is not divisible by, there is a remainder 1, so it is not divisible by 7, it's not divisible by 8 because this is an odd number. This is not divisible by 9 also because the sum of the digits is 10. It's not divisible by 9, it's not divisible by 10. I'll just check whether it is divisible by 11. 11 ones are 11 ones are 5. No, it is not divisible by 5. 11 also. 11 also it's not divisible. 12 also it's not divisible because it's an odd number. I'll just check 13. 13. 104. Just a minute. Give me 2 minutes. So 39 is, sorry, I had got a call. So 13 into 9 is 117. And then you have 13 nines 117. 3 plus 6 is 9. Then it is 91. 13 into 13 sevens of 91. So just 13 into 97. 13 into 97. 13 into 97 gives you 1261. So I will write this whole number as 1261 as 13 into. So finding this 13 and 97 is a bit difficult. Once you get that, so 97 cancels. 13 ones are 13 sevens are 91. That's what we have calculated here. So so this number is completely divisible by the denominator. So this will be an integer, and there is no decimal part or the remainder part. So the remainder would be 0. I hope this is clear. If you have any doubts, please ask. People who are not getting this were not able to solve, is this clear? If you have any doubts, feel free to ask. Okay, then we'll end the session here. Thanks for coming. Good night, and we'll meet tomorrow at 8 o'clock. Thank you.